Okay, folks, this is a video talking about the standard normal distribution, and specifically I'm going to talk about problem number 31 and the chapter 6 to chapter 6 to 9 study guide, the second study guide that you received. Okay, so here's the question. The average charitable contribution is $792, and the distribution of the contributions is normal. It's a normal distribution, and they're giving us the standard deviation. They want to find the limits for the middle 50% of the contributions. So let's take a look at my cartoon for that. Here it is. So it's normal. We know what sigma is. We know what mu is. That was given to us. So that's the information that we were given. 792 was the mean, and the standard deviation is 103. Okay, so what we're looking for is, what are these numbers here? If it's the middle 50%, if the middle 50% is in here, that means that 25% is over here and 25% is over here, right? So again, this problem could be this is a generic type of a problem. It's a metaphor for other problems. Any kind of a problem that might be on the final exam that deals with finding limits or finding, what's to the left, what's to the right. This is a good example of how to handle that. Okay, so what we need then is now let me talk about this real quick here. All right, the original variables are called x. You understand that, right? A random variable x. That's what your original data points are. Many times we don't want to deal with x. We want to deal with the z-scores, because the z-scores are so much more tractable. They're so much easier to deal with. Okay? So what we do is we transform the x's into a z-score. Okay, so how do we do that? How do we transform the x's, the original data, how do we transform that into a z-score? Well, we just use our formula. Z is equal to x take away mu divided by sigma. Okay, so it's very trivial to transform it. Okay, so what we're looking for are these values right here. What we really want is the z values. We want the x values, right? But it's too hard to calculate the x values. We transform everybody into the z values. The z values are very easy to calculate because we have the tables. All right, so we need the z such that 75% to the left of that z-score. You start here, you go to the left. You want 75% of the area under the curve to be to the left. Well, if you have that guy, by symmetry, you have this guy as well. All right. So what's it going to be? What value is, if I put it right here, what value do I have for z? What z value do I have such that 75% is to the left? Well, we get it from the table. It's real simple. Okay, now I'm cheating here a little bit because I already know what it is, but all you do is you just look up here, you find it. Okay, so like here it is, right here, 75.7517. So that's 75.17%. That's as good as we're going to get. Well, what is that number? It's 0.6. That's the row, and then the column is 0.08. So it's 0.68 is the magic number that we're looking for. Oh, all right, I have 0.67. Let me see, why did I do that? 0.67. Okay, I see why. Because this one is 0.7486. That's very close. That's a little bit closer than this guy. This guy is 0.0014 away from 75. This one is 0.0017. So this guy really is closer. So it's 0.67. All right, so that's why I chose that one. All right, so 0.67 is our value for z. So we plug that in right here. Here's our formula. And actually what I did on this particular one is I manipulated things to where I just kind of rearranged the terms. And after I get this formula, I go ahead and plug stuff in. So if Z is 0.67, 103 is my sigma that I was given. My mu I was given as 792. So now it's just a matter of cranking this thing out. Okay. So if X is equal to 723, that's what I'm looking for. So what I'm looking for is right here being 723. And that kind of makes sense, right? I mean, if the, hold on one second. Okay, sorry, I had a little technical difficulty there. Okay, so where I was at was you have the two different values for X here, okay? You've got, when you crank everything out, you've got 861 and you've got 723. So 723 is over here. The mean is 792. So if this is 792, I should have labeled that. If this is 792 and this is 723, yeah, it looks about right, because to the left of mu is 50%. So to the left of 723 sounds like it's about 25%. Same thing over here. If mu is 792, and then this guy right here is 861. I wish I would have labeled this. You have to do it on your own papers. If you have 861 here, that looks about right. So it passes the sanity check. It looks about right. And what I should have done, and I'm sorry I didn't, what I should have done is I should have drawn the cartoon again and plugged in those numbers to kind of get an idea. Okay, yeah, that makes sense. Okay, all right. So that's an example of dealing with the normal distribution. The concept here is you're going back and forth. You're going from an X score, that's the raw data. You're transforming it into a Z score so that you can use the table. And then once you have the Z score, you use this relationship right here, to tell me what is the appropriate X value, what is the appropriate original value that we're looking for. So if we're looking for, gosh, I kind of forgot what we're even looking for. It doesn't matter. This was charitable contributions. It could be anything. It doesn't matter what the random variable is. In this case, it's charitable contributions. It could be, how many people died. It could be how many people got well, how many people were arrested. It doesn't make a bit of difference what the actual random variable is. That's somewhat irrelevant. The important thing is, what is your X value and what is your Z value, and how can you transform back and forth? That's the concept that this problem is trying to illustrate for you. Okay, I hope that helped. That's the end of this tape.